Hi there. Last class we have seen the steps involved in the extraction of metal. The first steps we have seen is the concentration of ore. So what are the methods involved in the concentration of ore? Hydraulic washing, froth flotation, chemical process and electromagnetic separation. Based on the impurity, nature of the impurities as well as the nature of the metal, will go for the any one of the method to concentrate the ore. That is removing the impurities from the ore. Correct? The impurities is called gangs. Okay, so what is the next process in this extraction of metal is after concentration, whatever the ore may be, whatever the type of metal, based on the reactivity, first the ore has to be concentrated, that is removing of the impurities from the ore has to be taken place. Next process is that metals with high reactivity will go for the electrolysis. Okay, but metals with medium reactivity and the low reactivity, we will be converting this. The ore may be of sulfide form or carbonate form. Okay, that form has to be converted into oxide form, metal oxide. Okay, because metal oxide can be easily reduced to metals. Okay, that's why that is the aim of that. So what is the next process after the concentration of the ore? What is the next process? We are going to convert this ores into oxide form. Okay, that is the second process for both low reactivity as well as medium reactivity metals. Okay, so we'll see what are the how to convert the ores into the metal oxide. Okay, so why we have to convert them into metal oxide? First we'll learn that, then we'll understand easily. Okay, conversion of ore into metal oxide, because the metals can be easily extracted by the reduction of their oxides rather than from their carbonates and sulfate form. If the metal is combined with carbonates or sulfate, it is not easy to reduce the metal from that combination compounds. Okay, but if it is combined with the oxides, then it is easily reduced from that oxide. Okay, so that's why our aim is to convert the ore into metal oxide. So how will you convert the metal into rare metal oxides? Ore into metal oxides. There are two processes. Okay, the two processes used to convert concentrated ore into metal oxides are roasting and calcination. Okay, both are same process, only slight difference. Roasting means the sulfide ores are converted into oxides by heating in the presence of air. This is very important. Okay, when it is heated in the presence of air, that means in the presence of oxygen, that is called roasting. We'll go for this roasting when the ore is of sulfide ore. Okay, when it is a carbonate ore, the carbonate ores are converted into oxides by heating in absence or limited supply of air. Okay, in the limited supply of air, or otherwise in the absence of air, if we heat that ore, then it will be converted into metal oxide. Okay, so for converting the sulfide ores will go for the roasting method. Okay, the sulfide ores are converted into oxides by heating in the presence of air. Some of the ores are zinc sulfide, mercury sulfide and copper sulfide. This mercury sulfide have a common name called cinnabar. Okay, cinnabar. When it is heated in the presence of oxygen, the presence of air, it is converted into metal oxide, zinc oxide, mercury oxide, copper oxide, and leaving this SO2 gas. Okay, clear? Okay, next, calcination. Calcination means the carbonate ores are converted into oxide by heating in absence or limited supply of air. Carbonate ores are zinc carbonate, lead carbonate. Okay, when it is heated, it is converted into zinc oxide and lead oxide, leaving the CO2 gas. Okay, once it is converted into metal oxide, we can be easily reduced. Okay, next. So we have converted the ores into metal oxide. Then how will you reduce to metal? Okay, how will you reduce to metal? Okay, if it is of the low reactivity form, if it is in the low reactivity series, it can be simply heated. By heating alone, we can reduce to metal. Okay, reduction of metal oxide to metal. Next one is reduction of metal oxide to metals. metals that are lower in the reactivity series, that is the metals which are present in the lower bottom of the reactivity series can be reduced by heating alone. Okay, usually you know that this metals of low reactivity are all sulfide ores. Okay, sulfide ores, how will you convert the sulfide ore into metal oxide? Simply by heating in the presence of oxygen, right? On further heating, and the same process, on further heating, the metal is reduced. Okay, you can reduce the metal oxide to metal. Okay, you know, just now we have seen that mercury sulfide, that is cinnabar, in the presence of oxygen, when it is heated, it gives mercury oxide plus SO2 gas. Okay, on further heating this mercury oxide, HgO, on heating it gives Hg plus O2. Okay, this is your reduction process and this is your roasting process. Okay, clear on this? Likewise, for copper sulfide, on heating in the presence of oxygen, it gives copper oxide plus sulfur dioxide. Okay, on further heating, this copper oxide with the same, there's some amount of copper sulfide will be there, right? Copper sulfide, on heating it gives copper plus sulfur dioxide. Okay, this is your reduction process when the metals are of low reactivity. Okay, when the metals are in the middle of the reactivity series, if it is in the middle of the reactivity series, then you will have both carbonate ore as well as sulfide ore. Okay, if it is a sulfide ore, we will go for the roasting method. If it is carbonate ore, we will go for the calcination method. Okay, right? So once it is converted into metal oxide, then how will you reduce to metal? Means using the carbon. Okay, metals that are in the middle of the reactivity series are reduced by heating with carbon. In case of sulfide ore, it can be simply heated, you can get the metal. Okay, in case of this carbonate ore will go for reducing with the help of carbon. Okay, reduced by heating with the carbon, that is very important. Okay, zinc carbonate, on heating zinc oxide plus carbon dioxide. Okay, when the zinc oxide reacts with carbon, okay, in the form of coke, carbon, it gives zinc plus carbon monoxide. This is your reduction process. Okay, and it is reduced with carbon. Okay, likewise, lead carbonate gives lead oxide plus carbon dioxide. Lead oxide, and further heated with coke, carbon, it reduced to lead plus carbon monoxide. Okay, clear on this? Next, and in some of the places, in some of the places, this carbon is not used as a reducing agent. Okay, some of the highly reactive metals such as sodium, calcium, aluminum can be used as a reducing agent. Okay, this we have seen this here. We are using the carbon as a reducing agent, right? In some cases, in some places, we'll go for the sodium, calcium, and aluminum as a reducing agent. Okay, how it happens means, sometimes reduction is carried out by displacement process. Okay, instead of reducing metal oxides to metal by carbon, we'll go for the reducing of metal oxides to metal by the highly reactive metals. Okay, the highly reactive metals such as sodium, calcium, aluminum are used as a reducing agent. Okay, they can displace them. You know that it is highly reactive metal can replace the low reactivity metals from their compound, right? They can displace metals of lower reactivity from their compound, right? Magnesium oxide plus aluminum gives magnesium in molten state plus aluminum oxide plus heat. Okay, displacement reaction is a highly exothermic process, so heat will be evolved. Okay, that's why this metal is in molten state. Actually, it should be in the solid form, right? Instead of that, it will be in the liquid form, molten state. Okay, likewise, iron 3 oxide plus aluminum gives iron in the molten state plus aluminum oxide plus heat. Okay, Why it is given in the molten state means because of this high heat only. Displacement reactions are highly exothermic, hence a large amount of heat is evolved. Okay, due to this large amount of heat, metal produced are in the molten state, that is in liquid form. Okay, next. So some of the application of this using the highly reactive metal as a reducing agent in the place of welding. Okay, this is called thermit process or thermit welding. How it works means it is a process that uses the heat from an exothermic reaction to produce coalescence between the two metals. Okay, in the process of welding means what? Two cracked things will be there. You are going to join using a metal, right? Okay, this is of some other metal. This welding is going this welding stick will be the other metal. Okay, it's going to join, right? We are going to make a bond between this this is your welding, right? So for this welding purpose we are going to use this process. Okay, the reaction of iron 3 oxide with the aluminum is used to join railway tracks or cracked machine parts. Okay, this reaction is known as thermit reaction. Okay, because high heat and heat is evolved. Okay, this heat produced in this reduction process, right? Large amount of heat is produced, right? This process is used to join the railway tracks as well as the cracked machine parts. Okay, that process is called thermit reaction. It form a bond between the two different metals. Okay, that's all with it. We'll continue with the next thing with the metals of high reactivity using the electrolysis process. Okay, thank you.